Yep. All right, in section 5.6, we are solving polynomial equations by factoring. So in this section, what we are actually doing is taking a trinomial, in most cases trinomial, and we are going to be factoring it so that we can actually solve a quadratic equation. Now what's confusing is we didn't really go over what a quadratic function is, but a quadratic function has an x to the squared power, x to the second power, and then an x and then a plane number. And quadratic functions look like parabolas. So if I was to graph a quadratic, this is what it looks like, something like this. And quadratic functions, when you're trying to solve them, you're trying to figure out where the line or where the graph crosses the x-axis. Sometimes it's 2 places, sometimes it's 1 place, sometimes it's 0 places. So what we're doing when we're factoring is we're actually finding out the 2 answers to where this crosses the x-axis. And one of the prior things you will have to know for this is how to solve simple little equations like x minus 1 equals 0 and x plus 2 equals 0. So to solve something like this, obviously you would just complete the opposite operation. The opposite of minus 1 is plus 1. So this would be x equals 1, since 0 plus 1 is 1. To solve this one, we would subtract both sides by 2. 0 minus 2 is negative 2. So if we get to a certain point, once we get to a certain point after we factor, we're going to be solving these little equations, which means where does the quadratic function cross the x-axis? That's why we set it equal to 0, and then when we solve these little equations, those 2 answers, like in this case, x equals negative 2 and x equals 1, would be the solution to the quadratic. But it's kind of silly that we don't go over this first. We're like almost doing things backwards. So as we go through these types of problems, when we're solving quadratics by factoring, we're taking the previous knowledge of factoring and applying it to a new situation. So if we ever factor a trinomial and we get something like this, x minus 1 times x plus 2, and I say solve this, it's actually going to be the equation x minus 1 times x plus 2 equals 0. And we use something called the zero factor property to find the 2 solutions to where the quadratic touches the x-axis. What you do is you separate the little parts equal to 0 separately. Like x minus 1 times x plus 2 equals 0 can be separated into x minus 1 equals 0 and x plus 2 equals 0. Which is what we solved up here. When you solve these 2 equations, you get 2 separate answers like that, which actually says that the equation, the parabola, would cross the x-axis at 1 and at negative 2. A quadratic equation is an equation that's written in this form. We've been using this form this whole time that we've been factoring, ax squared plus bx plus c. But now what's going to happen is we're going to have an equal to 0 part on the right-hand side of it. And not only are we going to have to factor these things, but we're also now going to have to use the zero factor property to find the 2 solutions, or sometimes 1 solution, or sometimes 0 solutions that would occur for this quadratic equation. So this is an application to factoring. These applications are asking us to solve a quadratic equation by actually using the factoring method. The first thing that you would do, forget this equal to 0 part. The first thing you need to do is factor x squared plus x minus 6. Because the a number is 1, this is considered an easier type of problem. When the a number is 1, all you need to do is figure out what multiplies to be negative 6 and at the same time adds to be 1, because there's a 1 here as well. So what we'll do is we'll find the factors of negative 6, and then those factors need to add to a positive 1. So the factors of negative 6, I'm just going to find the factors of positive 6. 1 times 6 is 6. 2 times 3 is 6. In order to multiply to be a negative number, so in order to get a negative 6 as my product, one number must be positive, one number must be negative. And at the same time, those 2 numbers need to add to be 1. So 1 and 6 are too far away from each other because negative 1 plus 6 is 5. and 1 minus 6 is negative 5, so it's not this set. It's going to be this set of factors here since these are 1 away from each other. It's important that you pick the correct negative. The 2 would have to be the negative factor in this case because negative 2 plus 3 equals a positive 1. Because this is an easier type of problem since this first number, this a is a 1, we can now go ahead and just factor it. X squared plus x minus 6 would be in any order x minus 2 times x plus 3, and I'm going to write the equal to 0 part. So what we did is we took the trinomial on the left-hand side and we factored it. Now that we have it factored, we will take these two things and separate them using the zero factor property to find the two solutions to where this quadratic function crosses the x-axis. So what you do, since x minus 2 and x plus 3 are being multiplied, the zero factor property says we can take x minus 2 and set it equal to 0, and x plus 3 and set it equal to 0, and then solve these separately. This should be a very easy, quick little part. Once it's factored, we will just solve this using algebra, adding 2 to both sides. We're going to get x equals 2 as one of the answers, and subtracting 3 from both sides, we get x equals negative 3 as the other answer. So when a question is asking you to solve the quadratic equation by factoring, you factor what's on the left-hand side. You keep the equal to 0 part there. Once you have the trinomial factored, then you can separate it into two separate little equations. And what your answers are actually considered, they're called the roots of the quadratic, and it actually means where it crosses the x-axis. But this concept is something that we might not cover in Algebra 2. You'll see it later, but you'll have the skills to do this later when we get there. So the second question here that we're going to be completing, I guess we can just skip over to C since I have this up. We can try letter C. This says x squared minus 25 equals 0. Now when we're factoring quadratic equations, when we're factoring trinomials, sometimes there's going to be 3 terms, sometimes there's only going to be 2 terms. In this case, this one actually it did have 3 terms, and the terms would have been x squared plus 0x and then minus 25. I know that because the x part in the middle is not there, so I know that those two numbers cancel out. And I also know that because this is considered a perfect squares or a difference of perfect squares problem. Since this is a perfect square and this is a perfect square, I can easily factor this. Since the square root of 25 is 5, I can factor this into being x plus 5 times x minus 5. Now, I can tell that this is the way that it factors to be that because of looking at this x squared and the 25, knowing they're both perfect squares, it comes quickly and naturally. Some of you, it might not. Some of you might be thinking, okay, well, there's only 2 terms here. We're used to seeing 3 terms, so where is the middle term? Well, the middle term, 0x, when you're in math class, mathematicians always try and take out things that are not necessary. 0 times x is just 0, so it goes away, and you're only left with x squared minus 25. But you can still factor this using the same method. What multiplies to be negative 25 and adds to be 0? Well, positive 5 and negative 5 would be the factors you would need, since 5 times negative 5 is negative 25, and 5 plus negative 5, or vice versa, equals 0. Once you have it factored, then the next thing you're going to do and last thing you're going to do is set both of these little equations equal to 0. So we have x plus 5 equals 0 and x minus 5 equals 0. We'll solve these both by, in this case, this one I'll subtract both sides by 5. I'm going to get one of the answers is equal to negative 5. In this one we add 5. So the other answer I'll get x equals 5. So when you're solving quadratic equations by factoring, you will get answers for x as your final answer. And what you do is you factor those problems, and then after you factor it, separate them and set them equal to 0, and then solve. Sometimes you'll get 1 answer, sometimes 2, and sometimes you might not get any answers. Let's see what happens in letter B. So letter B and letter D are going to be different types of questions. These ones are a little bit more difficult. So if I look at letter B, the first thing I notice is that the A number, the first leading coefficient, is not 1, which means when I go to factor this process is going to take longer than normal. I like to first figure out if there's a greatest common factor that I can take out of everything, and I have 2, 5, and negative 12. There's not a common number or variable I can take out, so I have to deal with it. What I have to do is multiply the A number times the C number. A is 2 and C is negative 12. A times C is negative 24. So I need the factors of negative 24, and the factors need to add to be the middle number here. So we need to add to 5. So the factors of 24, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. In order to multiply to be a negative 24, one factor has to be positive, one has to be negative. So you're looking for the pairs of factors that they're 5 away from each other, because when you have one negative and one positive, it's kind of like you're using subtraction. So 3 and 8 would be the pair that you would need, since those are 5 away from each other. You need to equal a positive 5, so the only way to do that would be having a negative 3 factor and a positive 8. And unfortunately, at this point in the factoring process, you're not going to be just done. We have to now take the middle term and rewrite it as the sum of these two factors. So what I do is I rewrite this whole problem into either 2x squared plus 8x minus 3x minus 12 equals 0, or, I'm just going to rewrite this up here because I wrote this first, doesn't matter the order, or you would write it as 2x squared minus 3x plus 8x minus 12 equals 0. Now, depending on which way you write the 8x and the negative 3x, it'll change the grouping and change the way that your answer looks, but you will get the same thing in the end. So what I mean by that is if I do it this way, this first way that I wrote it down, the 2x squared plus 8x minus 3x minus 12 equals 0, I'm going to be factoring this by grouping, which means you put a line down the center. You can only use grouping factoring when you have 4 terms. Now we do have 4 terms, so I can separate this and factor out using the GCF. 2 and 8 shares a common factor of 2. X squared, x, I can take out an x as well. So I'm taking 2x out of each term. I'll be left with x plus 4 inside of parentheses, since 2x times x plus 4 equals 2x squared plus 8x. Then over here on the right-hand side, it's really important that if you have a negative number, you take out the negative in the very beginning. So I have negative 3x minus 12. I'm going to take out a factor of negative 3 from both factors here. I'll be left with x plus 4. So when I go to factor this completely and put it into its normal set here, I'll have 2x minus 3 times x plus 4, and then equals to 0. If you chose to rewrite the numbers this way up here, the process will look different, but your answer will be the same. So if I was to do it this way, if I put a line down the center and I factor this, I can only take an x out of these two things, so I'll be left with 2x minus 3. And 8x minus 12, I can take a factor of 4 out. I'll be left with 2x minus 3. So if you notice, the process looks different, but it's going to still give you the same exact answer, which is still x plus 4 times 2x minus 3 in any order. The last step in solving this problem is separating these two equations and setting both of them equal to 0. So this would be 2x minus 3 equals 0, and x plus 4 equals 0. What we are doing right now when we do this step is actually solving the quadratic equation by factoring. The whole point of factoring is what we're doing right now, which is actually solving for where it crosses the x-axis. This is something that you'll see in pre-calculus. This is something that you'll see in calculus. So if you're taking higher level math courses in your future, this is what you will need to know how to do. This whole process leads down to this, and this is like really where the calculus comes into play. Once you set these equal to 0, you should solve them quickly by just inverse operations. I get 2x equals 3. Then I divide by 2. One of the spots where this equation crosses the x-axis is at 3 over 2, or 1.5 in any format is fine. And then the other place where it crosses is going to be at -4. So on a quiz, what I would have you do is I would have it set up x equals, and you would just put in the number. X equals, you would just insert the number in any order.
On a quiz, would you have it like, would you say like this, and like, would we know the difference between like
Yes.
a quadratic equation and then just like a normal
Yes.
factoring?
So the questions are going to ask you to just strictly factor, or it's going to say solve this quadratic equation. The main difference is when you're solving it, you'll see equal to 0. If you're just factoring it, it'll just look like this. Factor 9x squared plus 15x. It'll just be done. So whenever you see an equal to 0 part, you have to do all this extra work, which is down here. And your final answer will actually be like just 2 numbers or one number, x equals something. For this last problem, before you're going to try some on your own, we are going to be first taking this trinomial, which doesn't really look like a trinomial yet, or just polynomial, I should say, and try and figure out, can I take any factors out? That's the first thing you would want to do. I see 9, I see 15, I know I can take a 3 out. I see x squared and x, I know I can take an x out. So step 1 should always be, can I take a GCF out? And in this case, you can. When you take the factors 3x out, you'll be left with 3x plus 5. Once I factor it using the GCF, I'm actually done with the factoring part. So this one's actually easier because I don't have to factor using the trinomial method that we did in the other ones, because factoring out the GCF will factor it completely. To know if something's factored completely, you look at the separate factors. 3x, that's factored. There's nothing else you can do with that. 3x plus 5, that's factored. There's nothing else you can do with that. I know that the 3x plus 5 is completely factored because the 3x and 5 share no common factors. If this said 3x plus 6, that would not be considered factored completely. So this is like one of your questions you had on WebAssign. When you have any common numbers here that share any factors, if that's at 3x plus 6, that would not be considered factored completely because 3x and 6 share a common factor of 3. But because these 3 x's and the 5 are considered relatively prime, that means it is factored completely. So what you would do is you would separate this into 2 separate equations, and it would be 3x equals 0 and 3x plus 5 equals 0. What you would do is solve both of these equations for x, dividing this by 3. 0 divided by 3 is just 0, so it crosses the x-axis at 0. And also, it would cross, and leaving it in improper fraction form is fine. It also crosses at x equals at -5/3. So the final answer to any problem that says solve the quadratic equation would be 2 or 1 answer for x, where it crosses the x-axis. Okay, so if we look at example 2 on the next page, we're going to just continue on with applying this zero factor property to solve quadratic equations. Now, all of the questions in example 2 are adding one more step to the process. In order to factor something that's a quadratic equation, when you're trying to find where it crosses the x-axis, it needs to look like this. So it needs to have some type of polynomial equal to 0. This is the important part. Whenever you don't have that to start out, you have to move things around so it does equal 0. So like right now, this says equals to 10. This says equals to 96. This is equal to 25. This is equal to 32x. So for all of these problems, the first step in solving these is actually moving that number, whatever number or term it is, to the other side so that it equals 0. So that adds one more step to the process. To move this 10 to the left-hand side, I can subtract both sides by 10, and it'll turn this problem into x squared minus 3x minus 10 now equals 0. Now that we have the equals to 0 part, we can start factoring. You cannot factor something that's in equation form if it's not equal to 0. Once it is equal to 0, now what we can do is factor x squared minus 3x minus 10. This is considered an easy problem because the coefficient, the leading coefficient here is 1. So when you look for the factors that multiply to be negative 10 and add to be negative 3, it should be quick and it doesn't require the factoring by grouping step. You just think of the numbers that multiply to be negative 10 and add to be negative 3. So if I still need to write these out, then on the side I would show my work. 1 times 10 is 10. 2 times 5 is 10. Those are the only pairs. I know that in order to multiply to be a negative 10, one has to be positive, one has to be negative. Well, if I make 1 negative and 10 positive, this would equal a 9x, and vice versa would be negative 9, so it's not the first pair. It's going to be the second pair. It's very important that you put the negative number with the correct number. So it's a positive 2 and a negative 5, or a negative 2 and a positive 5, and it does matter which is which. Which factor would have to be the negative? If the 2 is negative, negative 2 plus 5, is that what we need? Nope, vice versa. It's going to be a positive 2 and a negative 5 because positive 2 minus 5 equals negative 3. So what we would do here is then put it into its factored form as x plus 2 times x minus 5 equals 0, or if you reverse it, that's fine, as long as the minus sign is with the 5 and the positive is with the 2. You can rewrite it as x minus 5 times x plus 2. The last step would be to use the 0 property to split these up into two separate equations. X plus 2 equals 0, and x minus 5 equals 0. This is very quick and easy to solve. You don't have to show all of your work. If you can look at this and realize the answer is negative 2, and look at this and realize the answer is 5, that's great. If not, then you show all of these extra steps. And the two answers would be negative 2 and positive 5. That means that this quadratic crosses the x-axis at negative 2 and positive 5. Now, I know I just said, like, if you need to show all this extra work, if you're not, I know some of you are more like mental math people. Sometimes showing work is difficult. But I just want you to know for the next assessment, you will be uploading files of all of your work so that I can see the process to try and eliminate areas where you can cheat. So you will want to show all of that work. All right, so the next one, letter B, we would first have to move things around so that it's able to be factored. So the first thing I would do to move this 96 and make it equal to a 0 is subtract both sides by 96. When I do that, I'll be left with s times s plus 4 minus 96 equals 0. Now this one's kind of interesting because it almost looks like it's factored already, and then there's this minus 96 thing. So the first thing I'm going to do is actually do the opposite of factoring and is distribute, just so I can see what's going on here. So I'm going to multiply out s times s plus 4, and I get s squared plus 4s minus 96 equals 0. All right, now this is another easy problem because we are trying to factor this now that it's equal to 0. And we can factor this using the simple method since the coefficient is 1. So what I'm doing is trying to figure out what multiplies to be 96 and at the same time adds to be 4. So I can go ahead and just list all of the factors of 96. And I could take all the time doing that, and I can show you what I'm doing. I'm just taking my calculator. 96 divided by 2 is 48. 96 divided by 3, 32. 96 divided by 4 is 24. 96 divided by 5 is not going to work. 96 divided by 6, 6 and 16. 96 divided by 7 is not going to work. 96 divided by 8 would be 8 and 12. And then that's going to be it. We need to multiply to be a negative 96 and at the same time add to be 4. So the lucky pair of factors would be 8 and 12. In order to add to be a positive 4, the 8 would have to be negative and the 12 would have to be positive. So I could factor s squared plus 4s minus 96 into being s minus 8 times s plus 12. Once you have it in its factored form like this, then it's time for you to split it up into two separate equations equal to 0. I know I'm kind of running out of room, so I'm just going to continue it right here. This would be s minus 8 equals 0 and s plus 12 equals 0. To solve this one, I would add 8 to both sides. I get s is equal to 8. I would subtract both sides by 12. I'm going to get s equals negative 12. So that means that the two answers to where this quadratic crosses the x-axis is at 8 and at negative 12. Now I know this is kind of difficult stuff and each problem is different. That's what problem solving is all about. So what I want you guys to do is try C and D. Step 1 is put it into its general form, and you do that by moving the thing on the right-hand side, either by subtracting or adding it to move it to the other side so that it says equal to 0. Once you do that, you should try and factor it. Try factoring it by its GCF first. If that doesn't work, then try factoring it using the trinomial method. In a couple minutes, I'm going to give you guys some time to work. In a couple minutes, we'll go over the answers and then call it a day.